Welcome everyone. A very good evening. I am Jhumpa Mukherjee, Brand and Media Manager at Minimac Systems. Thanks for joining us today. We are very excited as the topic we are going to discuss today is really important and kind of one of the hot topics these days. Do you know, to limit the global warming in line with Paris Agreement, we need to cut the current greenhouse gas emissions levels in half by 2030 and reduce them to net zero by 2050. The demands for lubricants are increasing and eventually impacting the environment. There is a need to balance both. As the world is facing a climate emergency, industries are urged to decarbonize. Now, what is it? What is greenhouse gas emissions? Why carbon credit is important? How to earn it? Today, we are going to discuss how to earn carbon credits through better lubrication management. And we have with us Mr. Anshuman Agarwal, founder and managing director of Minimac Systems. We are sorry to inform you all that Mr. Yogesh Kumar couldn't join us because of some unavoidable situation. The flow of the webinar will be presentation, followed by Ask Me Anything session, which is an AMA session. Before we proceed further, I would like to remind you all to drop your questions and queries in Q&A box, not in the chat box. Stay with us till the end and don't forget to answer the poll questions during the webinar. So let's begin. Over to you, sir.
Thank you so much, Jhumpa. Welcome the audience. And I'm so glad that all of you have participated today for this very important, critical topic, which is not for our generation, but also the generations to come for our Mother Earth. Globally, the carbon credits, decarbonization, net zero, these are hot topics right now. And we would like to touch upon the points of lubrication management and how we can actually serve the bigger and larger purpose of net zero decarbonization and thereby earning carbon credits for ourselves. So this is a very primary approach we would be adopting because in this series of webinar, that's climate change and climate control, this would be the first one that we are organizing. And in coming days and coming webinars, we assure you that we would be coming up with much more detailed presentations and webinars over these topics. So let us start with the presentation for today. The topic for us is how to earn carbon credits through better lubrication management. So what we have done is we have divided this presentation into two halves. One, we would like to understand what are the various protocols around greenhouse gas emissions, what are these CO2 emissions, how they happen, how to manage them, what are the protocols around it. And then in the second part, we would talk about various scopes of lubrication management and how those scopes can help us in reducing the GHG emission into the environment. So as Jhumpa mentioned, we had certain commitments at the Paris Agreement of 2015, where all the member states agreed mutually that they would reduce the overall global warming, and they would limit it to 2 degrees versus the pre-industrial levels. Now, this is a very strong commitment because as of now, what we can understand is that the global temperatures are rising very fast because of fast industrialization. And that's why it becomes a very challenging task. So maybe this 2 degree would look very small, but eventually it will have a very long-term impact over the environment in the coming years. The second one is that this would be implying that thereby we have to reduce the greenhouse gas. Now the greenhouse gas, the GHG emissions by 80 to 95% as vis-a-vis to the 1990 levels by 2050. Very strong commitments, but yes, achievable. And due to these commitments and these understandings across all the nations around the world, there are various industrial sectors, various application areas where the GHG emissions can be reduced. A circular economy concept can be brought in. So we being a part of lubrication reliability industry, we thought we should touch upon those topics and scopes and opportunities where by a better lubrication management, we can reduce the possibility of GHG emissions. So here, just to sensitize the audience, we have a video which I borrowed from the Sky New over YouTube. I would like the audience to see it's a short video about what effect this global warming is going to have.
After the collapse of the Amazon and the carbon cycle, stabilizing global temperatures to avoid a 4-degree increase may no longer be possible. The global stream of migrants, which started with those seeking food and water, now includes millions fleeing coastal areas. Cities there will either vanish or become islands. In this temperature range, ice at both poles is certain to vanish, causing an eventual rise in sea levels of 50 meters. This will take hundreds, perhaps even thousands of years, but a sea level rise of even 1 meter every 20 years is far beyond our capacity to adapt. One place where adaptation is critical is China. While most countries' emissions have been largely stable since the start of this century, China's have gone through the roof. Today, the country produces 28% of the world's rice, 24% of the world's maize, and 18% of its wheat. In this future, Chinese agriculture crashes. The country needs to feed more than 1 billion people on 2/3 of its current harvest. By this point, 85% of the Amazon rainforest has disappeared. Summers will be longer, with soaring temperatures turning forests into firewood. Southern Britain could reach 45 degrees Celsius. Air conditioning is mandatory, which in turn puts more stress on energy infrastructure. There's a spike in emissions as output from coal and gas power stations increases, as hydroelectric sources literally dry up and renewables fail to take up the slack. The most damaging event at this temperature is the irreversible thaw of permafrost. At least 500 billion tons of carbon trapped below ground could be released by 2100. While no one's put a figure on the exact implications for global warming, the signs are ominous.
Thank you. So we do understand that the temperature is rising across the globe, and in recent times as well, we have experienced in certain cold countries where the maximum temperature, it shot up to the never before levels. Now, here's a poll question for all of us. Do you have carbon policy awareness in place? I would like to know whether you know the GHG protocols, what are the scopes under them, how are the carbon credits calculated? So there's a poll question for you, and there's the option of yes and no. The audience can tick it on the radio boxes. Okay, so can we have the results, please? So as I understand, a majority of our audience was very keen, and they would like to know about these policies and these protocols. So let's proceed to the next slide. What are these greenhouse gas emissions? So greenhouse gas emissions, maybe a lot of times we think that CO2 is the only pollutant in our environment, but it's not just the CO2, but a gamut of gases or harmful gases which are emitted from our various processes on the earth. And these gases stay a long period of time in existence in the environment or in the atmosphere. Now, CO2 is certainly one of the most dominant greenhouse gases, but of course, there are many others which we would like to see here, like methane, nitrous oxide, and a few of them which we would touch upon in the coming slides. What are global warming potentials? So basically, these gases, which are very, very harmful for the greenhouse effect in the environment, when they are emitted from the earth, they stay along for a longer period of time in the atmosphere, and that's why they become harmful for us. And it's not just the carbon dioxide, but it's also the methane, nitrous oxide, which have even higher effects. So the second predominant is the methane, and the third predominant is the nitrous oxide. And as you can see here, the methane has 84 times the global warming potential as compared to CO2. And the nitrous oxide has around 300 times the global warming potential as compared to vis-a-vis CO2. So if you want to see what are the various comparatives of various harmful gases, which when emitted into the environment, so this is a 100-year global warming potential calculation or a comparative data vis-a-vis carbon dioxide. Another poll question for you. Are you aware of scope 3? What is scope 3 of the GHG emission around you? What protocols are being followed under the GHG emission? So there is a protocol called scope 3. So the poll for the audience, you have to answer in a yes or a no. We can give another 10 seconds to the audience for the poll to wind up. Okay, so yeah, as we can see that 83% of our audience would like to know what are these scope 3 GHG emissions. And let's begin with the protocol. So this is the protocol diagram for the GHG emissions. And here we have three categories. As we can see, one is scope 1, which is considered as a direct. Another one is scope 2, which is considered as indirect. And then there is scope 3, which is a lesser known scope under the GHG protocol. So when we are reporting emission levels at our organization or our entity, we are the reporting company. The upstream activities before our reporting company processes are happening, these upstream activities like the purchases, the input goods, all those come as a part of upstream activities. And the downstream activities, whatever products we manufacture, the usage of it, the transportation, the distribution, everything comes as a part of downstream activity. Now, under these three different stages of our entire supply chain, the upstream activities, there are two different scopes, scope 2 and scope 3. The same with the downstream activities, there is scope 3 areas of GHG protocols. So before we understand this entire scenario of GHG protocols in our industrial setting, I would like to give an example or an analogy from the domestic setting. So in a domestic setting where possibly we have a house, and in that house, we are the reporting organization. I mean, by reporting organization, I mean the person or the industry or the entity who is going to declare how much GHG emissions are happening from their entity or because of their entity in place. So if we are considering our domestic entity, the house facilities, what we are having, those come under scope 1. So whatever house facilities we have which emit certain GHG gases, like the burning of LPG and cooking, the refrigerant application, or the burner application, or the air conditioning operation. So all of these would emit certain GHG gases as a part of our house facility or house operations facilities. The second is the domestic vehicle facility, which we use very commonly. And if we are using it for our own personal locomotion and transportation, that comes under the scope 1. So these analogies can help you understand that in an industrial setting, whatever processes are happening within the premises of your industry or your company, if those processes are generating certain GHG gases, for example, if you have a chimney which is responsible for generating certain gases out into the environment, so that comes under the scope 1. And the vehicles which you are using for probably doing the operations inside your plant and facility, So all those vehicles would consider to be as scope 1 generators of GHG gases. So if you have an effort to do to reduce this entire GHG gas emission from your premises as a part of scope 1 protocol, you would have to concentrate on all the processes which are generating the GHG emissions. And also the domestic vehicles, which I mean to say is internal transportation, which is happening within the premises of your facility. For example, if you have a steel manufacturing shop, and for that reason you have certain trucks, dump trucks moving inside or within your facility, so all those would come under the scope 1. Now, what is the scope 2? Again, going back into our analogy of a domestic setting. So the scope 2, as we understand, is understood as an indirect scope. By indirect scope, we mean to say we are procuring certain energies, and those energies, as in a domestic setting, are electricity, it's neighborhood heating, it's neighborhood cooling. So what we have done is we have basically outsourced the entire activity of electricity generation to a different plant or to a different premise. But certainly, as by the virtue of we using that electricity or we demanding that electricity, someone has to produce it. And that someone, by producing that electricity, would be generating a lot of GHG emissions. The same is applicable for the neighborhood heating, like in the cold countries, and the same is applicable for the hot countries, that's neighborhood cooling. So all of these where we don't actually do a process which would be manufacturing electricity for us or generating heating for us or generating cooling for us, it's basically someone else doing it for us, but we are responsible for all that happening around us. So that's why it is considered as a scope 2. By scope 2, that doesn't mean that it's a second priority, but it's basically just a classification of an understanding of how much we can contribute towards reduction in the carbon emission. So as a part of scope 2, the various activities that we would be doing is probably reducing the load on our electricity by having better energy efficient processes, by reducing the load on the electricity which is procured from the fossil fuel based sources, and rather have something else like an alternate electricity generation source within our own premises, so that the load on electricity purchases can go down. And if our demand for electricity, if our demand for neighborhood heating, and if our demand for the neighborhood cooling can go down by our efforts under the scope 2, yes, that would certainly be validated, and that would certainly be much appreciated. So as a part of this GHG protocol, scope 2 is what we just discussed. Now coming to the scope 3, the scope 3, as we understood, a part of scope 3 is upstream and a part of scope 3 is downstream. So in a domestic setting, once again, what is this upstream scope 3 that we can possibly contribute? So we all are aware that plastic bags usage has been banned across a lot of municipals globally. And that's one of the reasons why, you know, the scope 3 will be contributed by our little contributions when we reduce the usage of plastic bags, because that's something which we are buying along with the commodities which we are buying. And that's the purchased goods that comes under the segment of purchased goods. So if we can reduce the amount of purchased goods that we do for our luxury, for things which would have a very higher impact on emissions of GHG, possibly we can contribute to the scope 3. Now that's certainly something very debatable, wherein the various the humanities, they would say that we can't reduce our lifestyle and we can't reduce our activities around, otherwise what would be left for us? So yes, that's very correct, and we should be optimum in our approach on what we are buying and how we are buying. We should have that basic socio-environmental responsibility that let's go for something which is green. So because when we buy goods, when we are buying capital goods, when we are buying our usage goods, and we are doing a lot of transportation of goods around for our requirement, we are enabling these industries to work in a very higher level of setting, And those industries, if they are prone to generating harmful GHGs, that's certainly something that can be reduced if we can reduce the demand for specifically those goods which are generating high amount of GHG while they were produced in their factory setting. So this is what we can do by majorly reducing the amount of purchases for those prone goods which produce higher amount of GHGs. The same thing with this analogy, we can possibly have a classification of all our industrial input material. If it is critical, of course, we don't have an alternate. But if there are industrial purchases which have a very high level of emission factor while they were being produced, and possibly if we can reduce those purchases for our industry, we can contribute to the scope 3 as well for our industrial GHG plans and programs. Now coming to the scope 3 under the downstream setting. So again, understanding this through our domestic downstream requirements. So as a domestic downstream requirement, we are not commercializing anything, but yes, we do have a lot of waste generated and at our houses, and this can be e-waste, this can be plastic waste, this can be non-disposable waste. So what happens to this waste is also a very strong responsibility for all of us who have generated that waste. So do we actually go down to trace in terms of what the municipal does after it collects our garbage? Do we actually differentiate between the biodegradable and the other types of garbage? And do we actually check out what happens ultimately to those two different bins? Then we do a lot of e-waste generation as a part of consumerism across the globe. So what does happen to this e-waste when it is disposed of from our housing premises? So does our responsibility end up if we just dispose it off out of our houses? Certainly not. The exactly same thing is applicable when we are working in an industry setting. So there is a lot of industrial waste that gets generated during the processes of our companies. And this traceability of that disposal becomes very important. A lot of times we do the disposal of our goods through certified and licensed contractors or parties who do the disposal. But how many times do we understand what are the disposal methodologies that they adopt? Whether those disposal methodologies are having any emission factors over the GHG or not. So probably now our responsibilities need to increase. Just by selling it off to some disposal agency does not solve the purpose, but also to scrutinize and audit what happens further after the disposal is the most important contribution that we can make to the scope 3 downstream of GHG emission. So I hope this analogy between the industry and the domestic setting is clear to the audience. So thereby, let us move ahead now that we have understood what are the scope 3 GHG protocols. Let us come to the topic of discussion of today's webinar, that's lubrication life cycle and its management, and then the contribution towards the carbon credits and reduction in GHG emissions. So before we get into the topic of actual realization of carbon credits, let's first understand the entire lubricant life cycle. Because lubricant is a commodity which is manufactured mostly through the mineral oil raw material. And this mineral oil is which is coming from under the ground, that's a crude. It's taken into a refinery, and then from there, the base oil is manufactured. Now that base oil becomes like a raw material for the lube industry, who are blending the lubes in their factories in the blenders. So that raw material is the base oil. And from there, it goes into a production process. Further, it goes into packaging and then into logistics to the various distribution channels. Now, whatever emission we produce during the cradle to production gate, that's certainly the responsibility of the lube manufacturer. And the lube manufacturers across the globe, they have a very strong mandate to reduce this GHG emission during cradle to production gate for the entire life cycle of the lube at their end. But at now, what happens is they are extending their responsibility. A lot of lube companies across the globe, they have extended their responsibility towards
a step downward in the downstream supply chain or value chain, and they are taking it ahead to cradle to customer gate, wherein even the logistics arrangement of how these packaged lubes are reaching to the customer gate, even those are being considered as a part of their scope. And thereby, all of these, like the logistics or the arrangements in the downstream, they would formulate the scope 3 GHG protocols. And even further, if we go down the life cycle of a lube, till the time the lube is lost in operations or the lube is disposed of, that is the end of the life of the lube, if the lube companies they start taking certain steps and initiatives towards the end of life treatment of their sold products, again that would be contributing to the scope 3 of the GHG protocol. So what I mean to say with this slide is it's not just the responsibility of our company as a manufacturing company to take care of the GHG emissions within the premises of our factory, but also to ensure that the emissions linked to our produced goods, even they are controlled under the scope 3 of GHG protocol. And that's why it becomes very important that the usage or the life cycle of the goods that we manufacture from our production gate till the time it is the end of life, that's the grave for our produced good, we have a responsibility towards that as well. So if there are initiatives, programs taken up by lube companies towards end of life treatment and also the steps in the value chain till that stage, that is a very, very important step that lube companies can take today. So this is an elaborate understanding on what we talked about right now. There are these boundary conditions which are need to be touched upon by the lube companies. So the first row talks about the crude exploration and extraction, because a lot of lube companies across the globe, they are also the crude manufacturers or crude extractors. So right from the stage where the crude oil is explored, then extracted, then pre-processed, it is transported, it is refined in a refinery as a downstream activity, it is converted into mineral base oil. So all of these become a part of those upstream activities for a lube organization. Then there are also synthetic base oils which are produced in a separate chemical factory. So now what happens to these? As a part of lube blending activity, these are blended and they are formed lubricant. And these lubricant are taken to the customers for usage. Now, what the customers do for its usage and how and what activities they are involving around the lubricant usage also becomes a very important act here. After the usage of the lubricant is over, how is the lubricant disposed? Whether it is collected in a meticulous fashion, or is it that all the lubes are just mixed up together and disposed of to the recycler? All of these become a very important fact in the entire life cycle management, because each of these steps that we are talking about, each of them actually contribute to the GHG emissions. To understand the stakeholders in the lubricant industry, we have just classified into two different segments. The first one is the lubricant producer industry, which is all the lube blenders, whether they are integrated lube blenders who have the upstream crude oil facility as well, and those who are not having the crude oil facility, but they are blending at their location and then manufacturing this lube. So though all of them, they would be a part of the lubricant producer industry. And then we have the lubricant user industry, which is, of course, all of us like the steel plants, the power plants, cement plants, refineries, petrochemical plants, all of them. Wherever the lubes are used, all of them become a part of the lubricant user industry. And of course, then there are a lot of observers and catalysts around, like reliability companies and circular economy promotion companies who are working around these different sectors and contributing their own. So what are the responsibility areas? If we again touch upon the lube life cycle, so if this is a lube life cycle, a circular economy lube life cycle, to be very specific on this, So if we start off with this virgin oil, the virgin oil is taken into usage. So the virgin oil is produced by the lubricant manufacturer or the producer, and it's taken into use. So when it is taken into use, it becomes a responsibility of the lubricant user, that whatever GHG emissions are linked to the usage of lubricant, those need to be taken care of by the lubricant user. After the usage or end of life of this lubricant, it becomes like a waste oil. But is it really a waste oil? That is certainly a questionable or debatable point. Now, once we consider the end of life lubricant as a waste oil, the further treatment or the further handling of that waste oil is a questionable point. Now, whether it is just improperly disposed in the environment, probably by leakages or spillage, or it is just burnt off somewhere. So all of those become a part of that improper disposal, which is a responsibility of the lubricant user industry. And if there are certain user industry who are quite aware about proper disposal of lube, and they approach the used oil collection centers, and then they collect the lube oil at the plant, properly segregate them, and then give it away to the lube oil collector centers. So then the process ahead becomes a responsibility of the lube oil, waste lube oil collection centers. Now, again, they have two options. The first option is to just incinerate it, or just dispose it off in the environment, probably because there is no audit around me, or probably because the pollution control agencies are not so vigilant. So there are some improper practices, even with certain unstructured or unorganized players in the market. But the best practice would be wherein you regenerate that waste disposed oil by doing certain re-refining technologies and methodologies, and thereby you again produce the re-refined base oil, which can further be used by the blenders, and a circular economy is established. But this entire cycle, what we can see here, is beautiful to see, but how difficult is it to adopt and implement? That certainly depends on all of us, the stakeholders around. Few of us would be from the lubricant producer industry, few from the lubricant user industry, few from the recycling industry. So now collectively, we need to understand that there's a very strong and mandate requirement for the environment, wherein collectively we have to take a call on how this lubricant has to perform for a longer duration of time, how this lubricant doesn't become a chief cause for the GHG emissions. So now coming to the next part, that is how and what we can do for reduction in the scope 3 and scope 1 and 2 of the GHG protocols by having a better lubrication management. So this slide, I believe, would be one of the most important and the key takeaway slides for us as a part of this webinar. So as a part of the scope 3 of the GHG emission protocols, the scope talks about reducing the purchased goods and services. So while it talks about reduction in our procurement activities, especially of the goods which are having a very high emission factor. So what is this emission factor? Emission factor means if we are procuring a certain goods into our factory, while it was produced as a part of upstream activity by our seller, or the guy who is selling off that goods to us after manufacturing, or as a part of its distribution channel, the lubricant industry, as a thumb rule, they produce 1.007 CO2 per kg of lube purchased. So if we are reducing our lube purchases, possibly we are reducing against every 1 kg, approximately 1:1 ratio we are following, and we are already disposing of 1 kilogram of GHG emission into the environment. If we see the other part, the flip side of it, if we reduce the purchase of 1 kilogram of lube into our factory, we are possibly reducing the 1 kilogram demand of the lube to be purchased by the lube blender. And by reducing the demand, we are actually ensuring a reduced production of that lube. And by reducing the production of that lube, we are reducing the possible emission of 1 kilogram of GHG gases into the environment. So this is a long chain relation, but it is very well accepted under the GHG protocol of scope 3 emissions. The second possibility or actionable point for us is the disposal of the lube. Now, while we are doing the lube disposal, can we have a thought on the end of life disposal of the lube? While we are disposing the lubes from various applications because possibly we understand that the lube life is already over, have we carried out the conditioned monitoring activities? Have we tried an effort to understand whether it's actually an end of life disposal for the lube or just a mid-life disposal for the lube? So if we can identify by a better condition monitoring application in our factory for the lubricant industry, for the lubricant application, we can or we may identify a midlife situation where the lube can be reclaimed by certain methodologies, by certain technologies, and in-service lube, a midlife lube life can be extended. So while doing this, we can contribute majorly towards reduction in the lube disposal. Because if we can carry out this midlife reclamation and in-service lube reclamation, we can actually reduce the disposal of the lube. And by reducing the disposal of the lube, you won't believe the amount of reduction in the GHG that we can do. Because considering that our lube is going out into disposal and that is being incinerated, that's 11.72 kilograms of CO2 generated against every liter of waste lube, which is incinerated by our disposal agencies. So if the lube is being disposed by combustion, it's to the tune of 11.72 kilogram of CO2 generated for every liter of lube disposed by incineration of combustion. So what we can do here is by having a better lubrication management, we can actually achieve a better life or enhanced life for our lubricant. And by having an enhanced life for our lubricant, we can reduce the disposal of our lubricant from the factory. Now, coming to the point 3, for example, if we have already performed the best practices for lube management, but even after that, there would be certain amount of lubricant which is end of life disposal for the lubricant. Now, that is out of our hands and out of our scope, because we can't have a re-refining process for the small amount or medium amount of lubricant that we are going to dispose at end of its life. So in such circumstances, if we can identify and we can trace the disposal process of the end of life lubricant by identifying the re-refining process that's happening for it, by identifying what the downstream waste disposal agency is actually doing, and by tracing it, probably we can control the incineration process or the combustion process of our lube, thereby again gaining to the tune of reduction of GHG emissions up to 11.72 CO2. Of course, there's a calculation for the re-refining process of the lubricant here as well, but that would be considered in the upstream activity for the users of that re-refined lubricant. So as a part of the scope 3 for the lubricant user industry, this scope can be considered, these 3 scopes can be considered under the scope 3 of GHG emission protocols, and all the activities which can contribute towards reduction of emission to the tune what I explained, those can be adopted. And if those are large in numbers, probably we can start getting commercialized, validated certificates for those reduction in emissions. Coming to the scope 1 and scope 2 of GHG emission protocols, which are highly popular, because scope 1 and scope 2 give direct carbon validations, carbon credit validations by external agencies. And these are easy to calculate. These are easy to understand and highly popular, because a lot of industries who are producing GHG emission through their processes, or probably they are using extremely high level of energy requirements through electricity and heating, for them it's easy to identify. But as a part of the lubricant reliability process, what and how can contribute towards the scope 1 and 2 of GHG protocol? The first one is increasing the efficiency, the energy efficiency of our plant processes and machineries. So as a part of increasing the energy efficiency of our machineries, especially the lubricated machineries, what can we do? We all understand that when a lubrication system or a hydraulic system, it's having a lower efficiency or performance, that would lead to a higher load on the electric motors that are driving or they are powering the lubrication system. So by increasing the efficiency of our lubrication system, by having a better lubricant management at our machineries, we can possibly increase the efficiency of our machinery, of the lubricant machinery, and thereby reduce the load or the current drawn by the electric motors associated with that. If we talk about the thermic oil process lines, again, we know that there are certain inefficiencies in the thermic oil processes, wherein the thermic oils are used for heating for certain applications in our plants. And when the thermic oil degrades or the thermic oil has certain contamination levels, the efficiency of the entire process goes down. And when the efficiency goes down, that's the heat transfer efficiency goes down, the requirement of higher energy at the heat source increases. And if that requirement increases, we are following an inefficient process. We are leading to a process where we will require higher amount of energy for heating at the source, and that would cause a larger amount of scope 2 or scope 1 if we are generating our own heating. So that would lead to a higher amount of GHG emissions. The second actionable point would be wherein we can identify those GHG emission, those high GHG emission combustion application in our plants, where for certain instances we are using low efficiency or high GHG emission combustion for our processes. In order to understand this, I would take an example. So we understand that in a power plant, like a thermal power plant, of course, the emission levels are high. But as a part of the post-shutdown restart activity, I understand for the boiler startup, we use LDO and HSD-based fuels for the boiler startup after each shutdown. And this would lead to around 4 to 6 hours of running of those boilers on LDO and HSD-based fuels. And in a year, there are around 15 to 20 such instances in a power plant which happen due to unplanned shutdowns. So although this would be quite small in terms of understanding in numbers, but in terms of overall impact, if we talk about 15 to 20 instances of unplanned shutdown happening in our plant, and due to these unplanned shutdown, the boiler lighting up happening through LDO or HSD-based fuels, the amount of GHG emission happens because of the combustion process of the LDO and HSD-based fuels. It's even higher as compared to our normal process of power generation using fossil fuels of natural gas or coal-based burning. So this can impact directly to the scope 1 of our entire emission from our power plants. So if we can reduce that 15 to 20 instances of shutdown or a breakdown activity in our plants by having a better lubrication management, because we are well aware that 40% of breakdowns, mechanical breakdowns, happen because of lubricant reasons. So if we can reduce those 40% of breakdowns, we can actually reduce this entire shutdown-based emission by 40 to 50%. So understanding the scope, I hope is clear to the audience. So let us move ahead and understand various industrial sectors. Let us take each use case. So for that reason, we have identified a classification amongst the lubricant user industry, and we have classified it based on two factors. One is the criticality of the lube, and second is the lubricant replacement factor. By lubricant replacement factor, I mean If we are having a particular tank in our machinery and that tank is having X amount of liters of lubricant, how fast do we replace that lubricant? Do we replace it on a periodic basis, which is 3 to 4 times of frequency in a year? Or do we replace that lubricant over 3 to 4 years? Or do we replace that lubricant over a higher number of years? So if we talk about the steel, cement, power, paper, metal, oil and gas, refinery, and petrochemical, these are industries where the criticality of lube is extremely high. The criticality is high because they don't have standby lubricated machineries. They have just one single machinery which has to perform an operation. And if that's going to break down, the entire production will shut down. But when we talk in terms of the replacement of the lube in these industries, it has a medium replacement factor because they are not replaced on a yearly basis, but probably they are replaced on a 2 yearly basis or a 5 yearly basis, or in such certain industries, it might be replaced after 10 years of application. So the medium replacement factor is quite predominant in these industries. The second classification of industries is the mining, the construction, transportation. By transportation, I mean the railways or mass transportation, then the marine transportation. So all of these industries, the equipment, what they use, like the engines, hydraulic systems, and transmission systems, all of them would have a medium criticality because there you have a possibility of having or owning a higher amount of fleet in your assets. And if you have a higher amount of fleet in your asset, you always have alternatives. But the replacement factor for the lube is extremely high because a lot of such industries replace the lube in their hydraulic systems or the engine systems, the transmission systems on a strict periodic basis based on the OEM recommendations or the oil company or the lube company recommendations. And as these replacement factors are high, so proportionally, the purchase factor of lubricant also is extremely high vis-a-vis the other segment of industry. So when we are talking about the scopes of reduction of GHG protocols, if for this segment, that is the mining, construction, and transportation segment, if we can have in midlife or in-service reclamation policy for our lube, possibly we can achieve two different aspects. One, we can reduce the disposal of lube by a very large amount. And the second, as we would be having a reclamation at the midlife stage for the lube, the reduction in fresh lubricant would also be substantial enough for our industry. So the scope 3 protocol for these industries would be having a midlife reclamation policy for the lubricant usage in our plant or our facility. And then comes the plastic, auto parts, manufacturing, and engineering machinery and parts. So all of them are highly critical in nature, and also they have a very high replacement factor for the lubes. For example, you have the metalworking fluids or the rust preventive fluids, or you have the quenching oils. So all of them have to be replaced at certain frequency. And if not replaced, then probably the quality levels of your produced equipment or your produced goods that would go down. So with these classifications, we can possibly become much more sensitive towards the usage of the lubricant, as we have already understood what are the actionable points for us under the scope 3, scope 2, and scope 1 of GHG protocol. Probably we can start identifying those areas around us where we can have a better lubrication management and thereby contribute to the scopes, the 3 scopes of GHG protocol. So if we can contribute towards those GHG protocols, we can actually earn a carbon credit for ourselves. And the carbon credit market is already in place in the industry, which works in a sense like there is an emitter industry, which is emitter A, and there is a emitter B. So if the emitter A is increasing the amount of GHG emissions through their chimneys, and there is another industry that is emitter B, which is having a lot of carbon credits to their name, they can actually sell off those carbon credits to the emitter A, who has an excess GHG emission in place. and this would be sold off against certain currency, and that would be a commercial benefit as well to your organization. So if you think that there is an X amount of investment to be made and that needs to be economically viable towards your industry, there is a scope for selling off the benefits that you gain by having a better carbon credit to your name and a better carbon credit or carbon standing in the market. So how does this carbon credit ecosystem work? So there are certain carbon credit offsets which one can gain by having a better plantation, and these can be sold off to the emitting industries, the greenhouse gas emitting industries, and these industries have to pay off in currency to the industries who are sequestrations, CO2 sequestrations for the industry. Now, coming to the next poll question, are you aware of your used oil disposal process? I'm sure if you're a part of certain industry, you would have a used oil disposal process. So we talked about the incineration process, we talked about the re-refining process. So are you really aware about how it is being disposed? Do you have any traceability records with you while you are disposing of the lubricant to some recycler, as they call it, or some collection agency? What do they do with the lube that they buy from you and various industries around you in your neighborhood? So are you aware about that? So you can please be honest in your response, and we can have another 5 seconds to wait for the response from the audience. So the response is a mixed one. A few of us do say yes, and few of us say no. Now, whether it's an incineration process or a re-refining process, that's certainly something which the respondents in yes need to understand. And if your response is yes, you need to know whether it's incineration or re-refining. So after this webinar, if it's really an incineration process, probably you would have to take some actions around it, because as a responsible industry, if we are disposing the lubricant from our premises and if it's getting incinerated, we have a social and economical plus environmental responsibility for the industry and for the earth. Now, coming to the next part of this presentation, how Minimac can contribute towards the circular economy concept and what are the solutions that we can offer you. So we are having a very strong mandate towards the adoption of cost-efficient technologies and practices. Towards what? Towards improving the reliability and performance of your lubrication and hydraulic systems. So as we talked about this in the scope 1 discussion, if we can increase the reliability of our machinery, if we can reduce the breakdowns of our machinery, probably we will be a very good industry or a state-of-art facility for claiming the scope 1 and scope 2 carbon credits for our name. Then we would be contributing towards increasing the life cycle of your lubricant by having a better life for the lubricant, because we would like to identify the lubricant which is in the midlife, and in the midlife status or situation, we would introduce a reclamation process. Now, let me be very clear that reclamation is different from recycling. Reclamation happens for a midlife lubricant and recycling happens for an end-of-life lubricant. So while we talk about the end-of-life treatment, that is the recycling process, that's something where a re-refiner can help you out. A better disposal company can help you out. A better collection agency can have a solution for you. But when it comes to the midlife treatment or the in-service lubricant treatment, that would ensure a reduced disposal, as we talked about under the scope 3. And by reduced disposal, we can actually contribute to certain carbon credits for our name by reducing the scope 3, that is the waste disposal from our premises. So as a part of our offerings, Minimac offers products, services, consultancies, and awareness programs for increasing the lubricant efficiency and its life cycle. and also for improving the reliability and productivity of the machines. For this, we have various products and services. So the products what we offer are various lubricant purification systems or lubrication reliability improvement systems. The services what we offer are equipment rental services and contracts for one-time purification activity. And we also do a lot of condition monitoring activities. Then we have consultancies, technical consultancies around reliability improvement by lube assessment and lube practices assessment. And now recently we have launched circular economy consultancy through lubrication management. So all of these through expertise manpower are offered by Minimac company. And incidentally, today is the Engineers Day for the audience from India. So happy Engineers Day for all of you. And let's celebrate the power of engineers by having a moral, technological, and socio-environmental responsibility. Let's do our bit as engineers. Thank you so much, audience. Over to you, Jhumpa, to take the proceedings ahead.
Oh. Thank you, sir. Thank you, everyone. So now we will start with our Q&A session. So I hope you all are ready to ask your questions.
I think there's some trouble with the audio of Pragati. So we would like to announce the upcoming webinar. It's on 20th of October, and it would be on a topic of turbine control systems. The turbine control systems have a control fluid as an application, and the reliability and maintenance of that is quite important. So I would like to see the audience around for the next webinar as well. And now we can have the Q&A session, the AMA session for the audience. So I would like to request the audience to put up all your questions on the Q&A box. Okay.
Sorry for the glitch.
Yeah, Pragati, if your audio is working fine, then probably you can take up the Q&A session.
Okay, sir. So am I audible now?
Yeah.
Okay, sir. So the first question for the evening is, how about by Mr. Mukesh, and he wants to know how about using better performing lubricants so that waste oil generated quantity gets reduced. And the second part of it is, Indian industry is way behind as compared to international practice. Your thoughts, please.
So I would take the questions one by one. The first question, when you talk about better performing lubricants, so we need to be very specific on what kind of lubricant are we going ahead with. If we talk about a better performance, so whether it is a performance in terms of a longer life, or is it in terms of performance of its lubrication properties, or the enhanced additive levels, which would enable our equipment, the lubricated equipment, to have a better efficiency. So if we can identify those better performance areas and KPIs, the key parameter areas for our lubricant, then why not? We should certainly go for that. And even if we have to pay a premium for those better performing lubricants or specialty lubricants, certainly if we can have a better performance, we should do that. The second question is quite a geography specific question. And as we have a global audience out here, I would not really comment on whether some industry is ahead or some industry is behind, some country is ahead or behind. Ultimately, it's a collective responsibility for the entire globe and the entire fraternity of lubrication engineers around, or the mechanical engineers around, who are contributing towards anything or whatever they are doing their bit towards a better carbon credit for their industry. So certainly everyone has to work together, and wherever we are right now, whether ahead or behind, we have a long way to go ahead. So let us start right now as we understand and identify those areas in our application in industries, in our application functions, start working around it, possibly have some better implementations in place. And if yes, if we can identify that these contributions are substantially large enough, then why not commercialize it by having a validated certificate around it and trade that certificate for the benefit of the organization where we are working in.
So that was a great answer. Thank you, sir, for the answer. So we'll move to the next question, and the next question is by Mr. Greg. The question is, in continuous operating process industry, certain amount of redundant requirement are kept in process line as standby ones to work on the operating equipment, which is very much followed by them since decades. So could you please answer, sir?
But I could not understand what's that question, Ram, because
Okay.
I think it's a comment rather than a question.
Okay, sir. Let me just take it.
Are you taking
one
up
second.
from the chat box or from the Q&A?
Yes, sir. I think there is
Maybe you
some
can take
issue.
up from the Q&A.
Yeah, okay. So the question is, what is the LCA of oil reclamation or the actions required for better lube management?
I believe
And
LCA would be talking about life cycle assessment.
okay. So he has also asked, how do you get a carbon credit when three different certification bodies are required to quantify carbon footprint per project?
So the first question is how to assess the life cycle of a lubricant. So first of all, when you buy a lubricant from any manufacturer, there is a declaration of the overall life that this lubricant can last till. The second life cycle is demonstrated by the OEM of the lubricated machinery where that lubricating is going in. So these are the two different boundary conditions for us, wherein the OEM statement and the lubricant supplier statement needs to be honored and respected. Beyond this, what we can do is we can do an analysis of what exactly is the actual life that our lubricant is having in the usage, because the lifespans that are considered by the lube manufacturers, they are normally quite high, and they come up with certain riders. By riders, I mean they would be having certain recommendation and guidelines for the usage of the lubricant, which many times is not implemented in our industries. For example, I can understand that for wind turbine applications, the gearbox oil, which today is manufactured by various lube producers around the globe, they have a very strong commitment towards the life of that gearbox oil lubricant that's used for the wind turbine industry. It is possibly between 5 to 20 years by various different manufacturers of lubes. But in practicality, do we actually realize that amount of life? Because possibly the lube management was not done properly in place, the lube purification was not in place, the lube condition monitoring was completely absent. So what happens is, one fine day we realize that the breakdown of that gearbox has happened because the lube was not monitored efficiently, or the management of that lube was not done, and thereby we get a shorter life of the lube as compared to what was guaranteed by the lube manufacturer. So life assessment is very important in those regards, wherein you can link the lubricant performance, the condition monitoring of the lube, and thereby you can assess the life of the lube while it is in usage. And that's why we talk about a mid-life lube management rather than end-of-life lube management. The second question was regarding the carbon credits and the validations. So of course, there is a policy, there is a particular protocol which needs to be followed with regards to the carbon credit certification and a validation, because if you need to trade a certificate, it certainly can't be just a self-certificate. So when it comes to doing your bit, it's not always a commercial impact. When you are doing a bit to the environment, let us be a little more non-selfish and do our bit by contributing. But at the same time, what I mentioned, if the contribution to the environment is substantial enough, by substantial enough, I mean if you can do some heavy amount of investment and those can lead to a better contribution to the scopes, what we talked about. In those circumstances, there is a possibility to get your project certified or validated by third-party agencies, and thereby the certificate which is coming to your hand can be exchanged for currency with other industries. But just by the fact or just by the demotivation that a carbon credit certificate can be validated only by a long process, that should not stop our efforts towards the environmental contribution of the GHG emissions.
Okay, that was a great answer, sir. Thank you. So the next question is from Mr. Praveen Shah. He wants to know, I want to know synthetic oil and mineral oil used in cement industry responsible for emissions? If yes, then which one generates more?
So what I can say here is that synthetic oil and mineral oils or any other lubricants, when they are used in your industry, that is the user industry, that in your case is cement industry, the usage of a lubricant does not cause emission. They are not responsible for emissions. But yes, the better lubrication management can be responsible for reduction in emission. So there is a flip side to it. We are not contributing, but we are possibly contributing to the reduction in emission. So if we can do that, probably the other factors or other processes in our plant where they are causing the emission to happen, probably that can be neutralized by our better activities of better lubrication management. So as we talked about, if we have a better lubrication management, we can reduce the purchase of lubricant. If we reduce the purchase of lubricant, the emissions which possibly would have happened at the production facility of that lubricant, that would reduce.
Okay, okay, sir. So the next question is from Mr. Nilesh. He wants to know, what is the ROI in percentage by recovering the used oil in comparison to buying new one and disposing the used one?
Now,
I think used one.
Yeah, I got it. So yes, the usage of a re-refined lubricant and usage of a lubricant which comes from fresh base stock. Now, these are certainly two options for us as user industry. Now, a lot of it depends upon what kind of re-refining process has been followed and what level of base stock has been produced out of that re-refining process. A lot of fresh technologies and innovations have happened in the re-refining process. So if we are going to follow those wherein the lube produced is produced through an efficient process, the emissions during the lube production through the re-refining are not very high, and the base stock which is available to us as a part of the downstream of that lube re-refining process, it's also of a very higher grade, then yes, by high grade I mean to say any grade beyond base stock 2. So in those circumstances, between the two, we can buy any of those. But yes, as a part of our responsibility, we can go ahead with the re-refined lubricant vis-a-vis the fresh lubricant. Or in a lot of such circumstances, we can have a balance between the usage of the lube. For those areas where the re-refined lubricant is highly applicable, we can go as a priority to those areas. And for certain areas of our plant which are supercritical in nature, we don't want to expose those applications to a re-refined lube because we are probably not very confident on how the re-refining process has happened. Certainly for those areas, we can go for a fresh lube. So thereby we can have a mix of purchase between re-refined lube and a fresh lube stock.
Okay, sir. Thank you. For the next question is goes like, what do you think can be the challenges in carbon reduction?
The biggest challenge in this would be a will, a creation of a will, a motivation to do this activity. And when we have a will, there is a way, as we that's this very old saying. So if our audience can make a mandate for their industry, for their functional areas, that they want to do a carbon reduction, probably yes, the solution will follow. And the biggest challenge of having a will would be encountered successfully.
That was such a motivating answer. I think everyone will contribute to our carbon reductions. So, the next question is, what about the carbon or the waste that is generated during lubricant re-refining?
Yeah. So as we talked about lubricant manufacturing process, of course, during the entire lubrication manufacturing process, that's called as a cradle to production gate process. During that process, of course, emissions would be there. Any industrial process can't happen without any emission. But what we actually do is we neutralize those emissions by doing certain savings in emissions somewhere else. So as a part of the re-refining process, whatever emissions would be there, they need to be neutralized by the alternate disposal activity of the lubricant, that's the incineration process. So while we prepare a project report of waste oil disposal, there would be a vis-a-vis calculation between the incineration process and the re-refining process, and thereby a neutral solution or an optimum solution needs to be found out.
Okay. So the next question from it is from Nilesh Kothari only. Is there any portal on which carbon credit is currently going on in the worldwide?
So there are multiple agencies around the globe who are like catalysts, and they are companies or agencies who can ensure the trade of carbon credits across industries. Then there are agencies who are the certifying bodies. Then there are validation agencies. Then there are consultancy agencies. So a lot of stakeholders in this entire market of carbon credits. And if we are interested in the commercialization activity of the CO2 emission reduction, the first step we need to take is to understand internally what are the areas which are contributing towards a higher GHG emission. The second step would be to identify how we can reduce that emission level at our factory, or how we can contribute to the scope 1, scope 2, scope 3. By scope 3, actually, we can contribute largely towards reduction in the emissions. And once we have achieved that, probably we would have to approach a circular economy consultancy agency who can validate those understandings, and who can help us implement certain solutions around it. And then we can go to some validation agencies, certifying bodies, and earn for ourselves carbon credits. Possibly in the coming webinars, because 1 hour is too short to talk about all these downstream activities of carbon credit, we can certainly take up another session on that, and we can help the audience understand what are the commercialization activities of the carbon credits in the market. But that's something which is, once you have the carbon credit in place, that's something which is very common for all the activities what you can do against circular economy. But when it comes to specific to lubrication management, I believe we have shared with the audience a lot of such pointers where we can go back, we can ponder upon those points and come up with certain solutions around it.
Okay, so here comes the last question of the evening.
Yeah.
And the question is, how lubricant handling in a right manner can save the environment?
So the first point which comes to my mind is, if we don't handle the lubricant in a proper fashion, there would be spillage of lubricant, and that would go into the Mother Earth. And that particular lubricant going inside the earth is a potential cause of CO2 emission. The second pointer which I would like to talk about is not just the handling, but also the storage and fill up activity into the lubrication user area. So there, if we don't handle the lubricant properly, the lubrication would go bad. It would be contaminated. It would have a lot of pollutants within it. And probably the properties of that lube has already fallen down even before when we have actually used it. So a fresh lubricant handling becomes extremely important to us because we have invested in one of the best lubes. And then if we don't handle it, probably we are going to lose the entire performance potential of that lube. The similar fashion, if we talk about the handling of the used oil or the waste lube, the handling starts from the area where we drain out the lubricant from its machinery. And if we don't drain out and collect it and segregate it properly and store it properly, probably we are not giving the due to the disposal activity of the lube. And that becomes very important, not just for handling of the fresh lube, but also to the handling of the waste lube. So as I understand, there are a lot of industrial sectors where they have come up with certain cluster modules. By cluster modules, I mean to say they would have collection centers for the used lube, and they would have recycling or reclamation centers for the disposed lube, which is midlife. They identify the midlife and end life lube. The end life lube is segregated from the midlife lube, and that is disposed in the best possible fashion. But the midlife lube is taken into a clustered or a reclamation center. In the reclamation center, it can be purified, the properties can be retained, and it can be filled up back into the application areas.
Okay, sir. So thank you for the answers.
Yeah.
And I would like to thank all the attendees for coming up for our webinar. And I hope you liked the session. So please take up the survey as soon as this session gets completed. And we have posted the link for our upcoming webinar. So please do register, and we would like to see you all again. Thank you. Thank you all. Thank you, sir. Thank you everyone for joining.